In this question, it is given that let S is the set of elements 1, 2, 3, 5, 7, 10 and 11. The number of non-empty subsets of S that have the sum of all the elements a multiple of 3 is dash. You have to fill in the blank. You know that whenever a number is divided by 3, either the remainder is 0 or the remainder is 1 or the remainder is 2. Remainder 3 is not possible, and because when a number is divided by 3, remainder is either 0 or 1 or 2, it means every natural number is in the form of 3n plus 0 or 3n plus 1 or 3n plus 2. And we can extend this statement up to any number. For example, if I say when a number is divided by 4, remainder is sure to be 0 or 1 or 2 or 3. That is, I can say every natural number is in the form of 4n plus 0 or 4n plus 1 or 4n plus 2 or 4n plus 3. Most of the students proceed by this type of ways. But note that a very important thing I am going to tell you. It's very helpful in thinking the solution of a question. That thing is, as I told you, every natural number is either in the form of 3n plus 0, 3n plus 1 or 3n plus 2. It is also clear that the number which is in the form of 3n plus 2 can also be written as 3 into n plus 1 minus 1. That is, I can say 3 lambda minus 1. That is, I can say every natural number is either in the form of 3n or 3n plus 1 or 3 lambda minus 1, or form wise you can say 3n minus 1. That is, always using this concept, every number is either in the form of 3n or 3n plus 1 or 3n minus 1. Or similar thing, in case of 4, we will say every number is in the form of 4n or 4n plus 1 or 4n plus 2 or 4n minus 1. Instead of 4n plus 3, you will say 4n minus 1, because the form 4n minus 1 and the 4n plus 3 are same form. Because instead of 3, if I use minus 1, my calculation becomes easier. And it is clear that out of these, the numbers which are in the form of 3n, that is multiple of 3, is only 3. In the form of 3n plus 1 are 1, 7 and 10, and the numbers which are in the form of 3n minus 1 are 2, 5 and 11. These three numbers are in the form of 3n minus 1, these three are in the form of 3n plus 1, and this number is in the form of 3n. That is, the number in the form of 3n plus 1 are 1, 7 and 10. In the form of 3n minus 1 are 2, 5 and 11. And the question given to us is the number of non-empty subsets of S that have sum of all the elements a multiple of 3. Because he has not specified the number of elements in S, only condition is it should be empty. We'll have to take all possible sets with having one element, subsets of S having one element, subsets of S having two elements, and so on up to subsets of S having all the 7 elements. First of all, I count the number of subsets having one element, and this is the only set which is subset of S and sum of the elements multiple of 3. Let us find the number of subsets having 2 elements and sum of the elements should be multiple of 3. It's clear that for the sum of elements to be multiple of 3, one number should be in the form of 3n plus 1, other number should be in the form of 3n minus 1. Then the sum of those two numbers will become multiple of 3. And for this, out of these three, we choose any one, and for out of these three, we choose any one. That is 3c1 into 3c1. Number of ways are there in which we can make the set having 2 elements and sum of the elements multiple of 3. For example, in 9 subsets, one subset will be 1 2, other subset will be 1 5. In this way, 9 are there. For example, 10 5 and so on. There will be 9 subsets having 2 elements and sum of the elements should be multiple of 3. So far I have got 1 plus 9. And now we find the number of subsets having 3 elements and sum of the elements should be multiple of 3. In the case of 3 elements, for the sum to be multiple of 3, one element should be from here, one element should be from here, and one element should be from here. Then only the sum can be multiple of 3. Therefore, in the case of 3 elements, number of subsets will be 3c1 into 3c1 into 1c1, because there is only one element in it. That is, again I have got 9. And now one more thing is to be taken care of, that if all the 3 numbers are in the form of 3n plus 1, then also the sum will be multiple of 3. If all the 3 numbers are in the form of 3n minus 1, then also the sum of numbers will be multiple of 3. Therefore, in first case, when all the numbers are in the form of 3n plus 1, the number can be chosen in the way 3c3, because 3 elements are here. In the case of all the numbers in the form of 3n minus 1, then also the sum will be multiple of 3, that is again 3c3. Therefore, 3c3 plus 3c3 again, that is 2, and 9 plus 2 is 11. Hence, 11 subsets are there having 3 elements and sum of the element to be multiple of 3. And now, to find the number of subsets having 4 elements so that sum is multiple of 3, that will be there if 2 elements are of this type and 2 elements are of this type. Or take care, one more case is also possible, when 3 elements are of this type and 1 element is of this type, or 3 elements are of this type and 1 element are of this type. In that case also, sum of all the 4 elements will be multiple of 3. First case, when 2 elements are of this type and 2 elements are of this type, number of subsets will be 3c2 into 3c2 plus. Next case, when 3 elements are of this type and 1 element is of this type, that is 3c3 into 1c1. Or one more case, when 3 elements are of this type and 1 element is of this type, that is 3c3 into 1c1, that is 9 plus 1 plus 1, that is 11. Hence, 11 more cases are there in which the subset is having 4 elements and sum of the element is multiple of 3. And take the case of 5 elements. For the sum to be multiple of 3, it is sure that 2 elements must be of this type, 2 elements must be of this type, and 1 element must be of this type. That is, the number of ways will be 3c2 into 3c2 into 1c1, that is 9. Hence, in this case, number of subsets becomes 9, in which the set contains 5 elements and sum is multiple of 3. And In case of 6 elements, number of subsets having 6 elements and sum is multiple of 3. This will happen when 3 elements are of this type and 3 elements are of this type. That is 3C3 into 3C3, that is 1. That is one case is there in which the set contains 6 elements and sum is multiple of 3. It's clear that in case of 7 elements, sum of all the elements is multiple of 3 and there is only one subset which has all the elements. Therefore, plus one more case. Hence, total number of cases becomes 43. Hence, the answer to this question is 43.